Hey guys, I want to do a quick brief video on intersections of polar curves. So last week you guys worked with different polar curves of different forms. I just want to talk about how intersections in the polar plane are different than intersections on the rectangular plane. So let's say we had two polar curves, r equals cosine of theta and r equals sine of theta. So these two polar curves, if we were to plot them, we have our polar axis, the opposite of the polar axis, and then the axis at theta equals pi over 2. If we were to graph cosine of theta, it will give us this circle with a diameter of 1. And if we graphed sine of theta, it will give us this circle with a diameter of 1. So that's 1, and that's 1. So we have these two circles. Now it's pretty clear to see that these two intersect at 2 points, right here and right here. But what those points are is what the problem is going to be. We have to figure out what these would be. Now that's at the pole. But that doesn't mean the point 0, 0 is going to work. We aren't sure what it is until we do the algebra to get through it. So we need to find out, just using substitution, how to solve this system. So we can do sine of theta equals cosine of theta. Divide both sides by cosine of theta. So tangent of theta equals 1. Well, the values where tangent of theta equals 1 are at pi over 4 and 5 pi over 4. And cosine of pi over 4 is, root 2. So we will have, root 2 over 2, not just root 2, sorry. So root 2 over 2 comma pi over 4, and cosine of 5 pi over 4 is negative root 2 over 2, 5 pi over 4. And both of these satisfy that equation as well. So root 2 over 2 comma pi over 4 would be going pi over 4 on the angle, root 2 over 2 from the pole. That will bring us to this point. And then negative root 2 over 5 pi over 4 will be going 5 pi over 4 as our angle, and then going root 2 over 2 backwards, which will bring us to this point as well. So this is actually both of those. And this, it's a physical intersection, but it's not a polar intersection. This point exists on both circles, but not at the same polar moment. So this is not an intersection of both. If you did 0, 0, if you plug 0 in for the angle, well, cosine of 0 is 1. So when the angle's 0, they're at different places. Sine of 0 is 0. So there's no common angle that would make them be both 0 units away from the pole. So this is a physical intersection, but not a polar intersection. We just have one polar intersection here. So let's try one more. Let's say we had r equals cosine of 2 theta. And r equals 2 cosine of theta. So if we were to look at the graphs of these, the first one, it's a rose curve with 4 petals because n is 2, so it's even. So the number of petals is twice n. And since it's a cosine rose curve, each petal is going to be 1 unit away, starting here, and then every quarter of the whole circle. So it would be like this. Oh, that's just, oh, that's just ugly. Let me try that again. Sorry, I can't talk and draw that at the same time. I actually had my tongue out like Michael Jordan as I was doing that. And this one is cosine of 2 theta. It's a circle like this with a diameter of 2. So that's 2. And that's 1 and 1. So if we look at it, it looks like we have 1, 2, 3 intersections. But we won't know until we do the actual algebra to get it. So we would just solve the system. One of these, or 2, or all 3 may not be polar intersections. They may just be physical intersections. But let's see. We set them equal. Cosine of 2 theta equals 2 cosine of theta. So 2 cosine squared of theta minus 2 cosine of theta minus 1 equals 0. So it's a quadratic. Cosine of theta equals the opposite of 2 plus or minus the square root of 2. Oops, 2 squared. Minus 4ac, so plus 8 all over 2a. So that's 12. Root 12 is 2 root 3. And everything's divisible by 2, so it's 1 plus or minus root 3 over 2. So that's cosine of theta. So that means r, we would have a point where it is 2 times cosine of theta. So 1 plus root 3. And another one where we would have 1 minus root 3. And the angle for this one would be cosine inverse of 1 plus root 3 over 2. And this one cosine inverse of 1 minus root 3 over 2. This one's positive, that one's negative. 1 plus root 3 over 2. All right. So this one would actually give us this, and this one would actually give us that one. All right. So this, again, this polar one, it doesn't give us the same thing again. Like if you plugged in 0 for your angle, cosine of 0 is 1. 2 times 1 is 2. So this one, it would be the 0.20. Cosine of 0 is 0. This one would be 0, 0. So that intersection is a physical intersection, and these two are the two polar intersections. All right, hope that makes sense. Have fun. See you later.